this was 3 units to the left of 0. 180 degrees means it's way over here. I'm going to draw this number line.
It represents negative.
But then why would it be a 0? Wouldn't it be 180?
Nope. Okay, the 0 degrees part tells me that I'm 5 units away from 0 over here. It's kind of like absolute value.
Yeah, but when you end up on the left, on the right?
Nope. This 3, 180 means face left and walk 3 steps this way. So where does that leave you? It leaves you at 2 on the side that is 0 degrees from 0. So this really is the same thing as 5 plus negative 3. Okay, so addition and subtraction, I hope, are fairly straightforward. Yes?
Can you just think of it as the 0 degrees represents positive and the 180 represents negative?
Yes.
All right.
You can think of that the whole way through this. Okay? Now, and then you'll be able to do addition in this system very easily. Now, the part I'm not going to prove step by step works for you, but I have done actually before using something called vectors, is how multiplication works. And here's what he figured out was the rule for multiplication. Okay? Yeah, write this part down. Might be a bonus on the next test. Multiplication. Okay? The rule is you multiply the numbers, you add the angles. Not going to work out the formal proof of why that works, but I have done so, so take my word for it. Okay? And once I did that, I realized something I'd wondered about since 8th grade was actually true. Multiply the numbers, you add the angles. Okay. So let's say I ask you what is 2, 0 times 2, 0. Okay? Brian, if you just change these into positives, what do you get?
You get 4.
You get 4 because it's 2 times 2. Positive 2 times positive 2.
And then 4, 0 degrees.
Yep, so if you break it, and that works with his rule, because you multiply the numbers and you add the angles, which gives you 4, 0 degrees. If you're going to invent a new way to think about numbers, then in your new way to think about numbers, 2 times 2 really should equal 4, if you want people to use it. Does that make sense? Like if you come up with a new idea, you got to check it to make sure it still works with what you know by counting on your fingers.
But if you're just making it up, then how do you know it's real?
Well, because it's got to be logically consistent if it's going to be... You know what? That's a good point. Real is the wrong word. I should say useful. You can make up all sorts of crazy math if you want to. I'll give you another example of it at the end of a system somebody came up with. But if no one has a use for it, either counting change at McDonald's or building a better aircraft carrier, then that math is just not going to catch on. So believe it or not, all the crazy math we're teaching you, somebody somewhere has found it very useful in the history of Western civilization. Yes? Yes. Okay, so 2 times 2 does equal 4 under this. But remember, you multiply the numbers, you add the angles. All right, let's see what happens with negative numbers. What is 3, 0 degrees times 4, 180 degrees? What's that going to get me? 12, 180. What's good? So it's going to be 3 times 4 for the numbers, 0 plus 180 for the angles, which is 12, 180 degrees. Brian, translate this into the math we all are more familiar with.
The 12, 180?
Yeah, well, the whole thing. 3, 0 times 4, 180 equals 12, 180.
3 is, it's 3 away from the 0. Wait, on the number line you're saying?
I just mean tell me what this looks like if we were just doing it with the numbers you're used to.
Like, what does it look like on a number line?
Brian is about to write me a history paper. Micah?
3 times, wait, yeah.
Yeah, 3 times.
Negative 4.
3 times negative 4
Equals negative 12. Sorry.
equals negative 12. It's okay, Brian, you were trying to give a good answer. Yeah, this is the same thing as 3 times negative 4 equals negative 12. And that's what we're used to seeing as being true, right? So far this guy's rules work the way we would hope they would work. They don't contradict what you've been taught on and off from... Sarah, what grade did you say? You learned negative numbers in?
I said 7th grade.
Said 7th. Okay, yeah. So far we haven't contradicted anything you've learned since the 7th grade, right? Okay, now,
He made it more complicated.
It does make it more complicated, but doesn't contradict it. Okay. 5, 180 times 2, 180. Okay. What's this going to equal?
10, 360.
10, what, Sade? 360.
Really?
10, well, the rule is you multiply the numbers and add the angle. So 10, 360. Well, that's a great question. This gets a little bit confusing here. Here's my 0. Okay.
No, that's not.
Here's my.
You wrote on your wall.
I did a while ago. You're slow noticing. Here's my 5, 180. I'm sorry. That is incorrect. Here is my 2, 180.
No, wait.
Here's my 5, 180. Okay, now, here's 0 degrees, right? Turn 180 degrees from 0 degrees, and you're facing the opposite direction, right?
Oh, I get it.
Turn another 180 degrees, and where are you?
Back over there.
Back over here where you came. So what's the difference
What?
between...
Oh, that's complicated.
So what's the difference between 0 degrees and 360 degrees?
306.
You go, it just brings you right back.
Brings you right back to where you're facing. Nothing practically, okay? So that means if I am facing that bookcase over there, and I go 360 degrees, I'm back to facing that bookcase over there. Sorry, Major. Okay, so I multiply a negative times a negative, and which way am I facing?
Positive.
Positive. So a negative times a negative does seem to equal a positive.
See.
Oh, okay.
This was actually, once I worked out the proof of this myself with vectors, I was like 30 years old, and I finally believed that a negative times a negative was a positive. I kind of doubted it up till then. I found a history book on my own, a math history book, actually. No college course ever taught me this. Yes, they taught me similar stuff that made this easy to figure out, but yes, some of which we'll get to.
I'm trying to get it, but how do you know 180 is
You
negative?
laugh like that.
Well, okay, at some point, every number system starts with some arbitrary decisions that people just make. 180 is just what we choose to call. I mean, 180 was defined literally about 5,000 years ago to mean the opposite of the way you were facing. Its whole idea, somebody picked the number 360 to be the number of degrees in a circle. And if 360 is the number of degrees in a circle, then 180 is halfway around. Why was 360 and 180 chosen? I don't know. The ancient Sumerians loved multiples of 5 and 12. That's why we have 60 minutes in an hour.
Really?
Yeah, they like 5 and 12, yeah. That's why our clocks are the only things that aren't base 10 in our lives. And there's 60, which is 5 times 12.
Yeah.
The ancient Sumerian loves 5s and 12s. I don't know why they did.
Or it could be 6
Pardon?
times 2.
Ancient Sumerians, they lived way before
Mesopotamia.
anybody. Actually, they were the first people to organize cities and write down math. So they're the earliest written math we have, and they loved 5s and 12s. Sumerians and
Are
Babylonians.
they the ones who made up?
They made a version of math. It's not the version that we use today, or else we wouldn't count to 10 and start over. We'd count to 5 or 12 or 60.
We don't.
Yeah, we do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11.
Are they the ones
1,
about
1,
half this
12,
religion?
1, 2. Place values. We have a base 10 system.
You know,
Oh, my Lord. Okay.
Bro,
All right.
That is
Wait, no,
so
bro.
I
annoying.
get it.
Yes,
Was math
thank
their
you.
religion or something? You said something about like some people believe that math was like their religion or something.
That was until later, till ancient Greece. I don't know what the Sumerians believed in. I know this much about their math.
Ronnie.
Anyway, okay, so a negative times a negative is a positive, okay? So according to this system. Now, multiplication was actually fairly simple. Now we get to the complicated stuff. Division, we're not really going to... So much. Okay, division not so much, but what we're going to get to right now, we're going to jump up to exponents. We're going to jump up to exponents for a moment, okay? Now, exponents had a different rule, okay? The rules for exponents were raise the number to the power, raise the number to the power, okay? Multiply the angle